So students, now we shall look at some few numericals on ideal gas. So this is numerical 1. A tank of 0.34 meter cube contains H2S at 22 degrees centigrade, the hydrogen sulfide. When 2.3 kg of gases are drawn out, the temperature in the tank becomes 15 degrees centigrade and pressure is 10 bar. Find the mass of the gas in the tank initially and its initial pressure. So, what is given here? First is the tank volume, that is 0.34 meter cube. Then the gas is given, hydrogen sulfide. Then the temperature is given, initial temperature 22 degrees centigrade. So next what they are, 2.3 kg of gas is drawn out. So the temperature falls to 15 degrees centigrade. And the pressure now is 10 bar. So what is the question asked is, what initially what was the tank gas, mass of gas in the tank, and what was the pressure? Temperature was given as 22 degrees centigrade. Now molecular weight of hydrogen sulfide, H is 1, so H2 means 2, sulfur is 32. So you please you have to remember, and how you remember, I'll just simple, I'll tell you. Hydrogen is 1, H is 1, carbon C is 12, okay, nitrogen N is 14, oxygen O is 16, sulfur S is 32. This is how I have remembered. So in ascending order, you can also remember 1, 12, 14, 16, 32. So 1 is hydrogen, 2 is 12 is carbon, 14 is nitrogen, 16 is oxygen, and 32 is sulfur. So here H2 means 2 plus 32, that is 34. Now universal gas constant R bar, that is fixed as 8.3143 kilojoules per kg mole Kelvin. So now particular gas constant, now for hydrogen sulfur, one you have to find out, R is equal to R bar divided by M. So R bar is 8.3413 and M is 34. So dividing 8.3143 divided by 34, we get R, the gas constant, is 0.2445 kilojoules per kg mole Kelvin. Okay. Now mass of the gas left in the tank after 2.3 kg of gas is drawn. So M is equal to P2. We know that PV is equal to MRT. Okay. So PV is equal to MRT. Now here now for condition 2. So rearranging this, what you get, M is equal to PV by RT. For condition 2, volume is same, R is same. So we are not writing V2 or R2. Okay. Only pressure was changed and temperature is changed. So we are written P2, T2. Volume and R is fixed in this case. So substituting the values of P has told the 10 bar. 10 bar means 10 into 100, that becomes in kilopascals, into V, volume is 0.34 meter cube given, divided by R is 0.2445 we have calculated just now, and temperature T2 is 15 degrees centigrade. So 15 plus 273, that is 288 Kelvin. So we have to be very careful in this ideal gas equation. This temperature has to be always in Kelvin only. So mass M is equal to 1.83. So 4.83. So the original mass in the tank is 4.83 plus 2.3 which was drawn out, that was 7.13. Now again using the ideal gas relation for initial condition, that is condition 1, PV is equal to MRT. Okay, now we have to find out P here. P is equal to, for condition 1, M1 RT1 divided by V. Okay, so that is M1 is mass you have found out 7.13, R is 0.2445, T is again 22 plus 273, that is you get in Kelvin, divided by volume. Volume is 0.34. Okay, now this we will multiply it with 100, so that you will get it in the pressure, you will get it in bar. So the answer is 15.13 bar. So what is the significance of this problem is, in this problem they are given a tank with a certain volume, that is 0.34 meter cube volume, which is a gas, hydrogen sulfide, and the initial temperature, that is T1. Okay, so volume is V. This H2S, you calculate, based on that you calculate the molecular weight, that is 2 plus 32, that is 34, and T1 is 22 degrees centigrade, that you add 273, you will get as T1 in Kelvin. Now next is so condition 2, when 2.3 kg of gas is drawn out, then the temperature becomes 15 degrees, so you add again 273 to convert it into Kelvin, and the pressure is 10 bar P2. So what is asked is initial temperature and pressure of the initial mass of the gas and the initial pressure. So very simple thing, we have calculated the molecular weight first, then we have found the gas constant for this particular gas, because we know R now universal gas constant, we know R bar, that is 8.3143, that is fixed, and then molecular weight we know. So universal gas constant divided by the molecular weight will give you the gas constant for this particular gas, that is a hydrogen sulfide, that we got as 0.2445. Now for the final condition, mass is equal to PV is equal to MRT. Rearranging, we get M is equal to PV by RT for condition 2. So substituting value P2 into V divided by R into T2, and P, because it is given in bar, we are multiplying with 100 to get it in kilopascals. The mass we get as 4.83, and 4.83 plus that 2.3 kg gas which was taken out, you get the initial mass as 7.13 kg. Now again using the ideal gas relation, PV is equal to MRT, we are finding out P because we know MRT and V. So here again the volume we are dividing by 100 so that you get it in the pressure in bar. Otherwise, if you don't divide, you can write just it in kilopascals. Okay, so this is how you solve a problem. Means you can find out the various, if one unknown is there, you can find out the other things using the ideal gas relationship. P, V, M, R, T is equal to MRT. So there are 5 condition things here. If one is unknown, you can find out by using this relationship, and this relationship you can use for initial condition as well as final conditions, no issues. And only thing you have to remember is, if the pressure is given in bar, you have to multiply it with 100, one thing. Second thing, temperature you have to take in Kelvin only, always, number 2. And the third thing is you have to find out the molecular weight of the substance, and then divide this molecular weight by the universal gas constant to get the R here. This R is not a universal gas constant, this R is for the particular gas, and to find out that gas you should know the molecular weight and then divide the molecular weight by the universal gas constant. This is how you get R. T you get in Kelvin, mass may be given or you calculate. P is in pressure, means in bar, means you multiply with 100, and volume should be in meter cube. This is how you solve the numericals. Thank you.